Hello, AP Chem students, and welcome to Section 5.4, Elementary Reactions. The learning objective for today is 5.4.a, represent an elementary reaction as a rate law expression using stoichiometry. This one will be short and sweet. So let's dive in. So molecularity. So most chemical processes that we represent with an equation actually happen through a series of smaller steps that add up to give the overall reaction. And we'll look at this a little bit more as the course goes on. But let me just show you. So you're used to seeing a reaction look like this. So 2NO plus O2 yields 2NO2, but actually it happens in two steps. So we have an NO that reacts with an O2 to produce NO3, and then in step 2, NO3 plus NO yields 2NO2. Okay, or it could happen this way. This is a possible way for it to occur. Each one of these smaller steps is called an elementary reaction. So the rate law for each of these can be written from its molecularity. And so molecularity is the number of species that enter a reaction. In other words, the stoichiometry. So I've been telling you all unit that you cannot just look at the stoichiometry of a reaction and determine its order. And that's because when we're looking at a reaction like the top reaction here, it's actually broken down into these steps. And that's why you can't write the rate law from the stoichiometry of the overall reaction, because the rate is actually determined by one of these steps. Now, if you know that you're examining an elementary reaction or an elementary step, then you can determine the rate law from the stoichiometry. And we're going to examine this idea more in the rest of Unit 5. So for these reactions, the rate law is determined purely by the stoichiometric coefficients in the reaction. Unimolecular reaction is a reaction involving one molecule. A bimolecular reaction involves a collision of two molecules. So you could have A plus A yields a product, that would be bimolecular, or you could have A plus B. So it could be two of the same thing or two different things, it doesn't matter. And then a termolecular reaction requires three molecules to collide. But reactions requiring the collision of three or more molecules are rare. And that's because in order for this reaction to occur, the multiple species would all have to collide in the correct orientation at the same time, which is just kind of unlikely. So a termolecular reaction would look like this. So you could have two of the same thing, one different thing. They could all three be different. So these are elementary reactions. And that is literally it for this topic. So then what should you be able to do with this? You should be able to use coefficients of the elementary steps to determine the rate law. And that's it. And we are going to use that fact moving forward. So please do make sure that you understand that. And so let me just go back and show you an example real quick before I sign off here. So if I were to go back here, I could say my rate is equal to K times the concentration of NO times the concentration of O2. Or here I could say my rate is equal to K times the concentration of NO3 times the concentration of NO. That's it. And I will see you soon for topic 5.5.